dividing radical expressions. Okay, so we're going to do simply that. We're going to multiply and divide expressions that have radicals within them, or as a part of them. A couple things it tells you early on, right here, knowing, and this stuff you've been told for a long time, my class and others, knowing the perfect square is greater than 1 will help you. It's just going to help you move faster. It's going to help you move smarter. It's going to help you get from thing 1 to thing 2 really a lot easier. Okay, so let's look at property right here. When we're combining radical expressions, if the index is the same, so we have an n and an n, then we can put them underneath the radical and multiply them together. Okay, so here's what that looks like. Can you simplify these? Well, that's a 3, and we don't write it, but that's a 2, so the answer there is no. That can't be, we can't simplify that. But because this is a 3, and this is a 3, we can multiply those, get -8, take the cube root of it, and get -2. Okay, so only when the indices, plural for index, you're impressed, only when those are the same can we do that. So go ahead and take a second, pause the video right here, just yes or no if you can, or if you can, do it. If you can't, just say no. And pause the video now, try those. Alright, you've unpaused, hopefully you said no to the first one, and yes to the second one, to multiply -5 times -2, and got 10. And it's the 5th root of 10. Easy as that. Alright, let's take a look here. If the radicand of the nth root of a has a perfect nth power among its factors, you can reduce the radical. If you reduce the radical as much as possible, the radical is in simplest form. We've been doing this since way long ago in Algebra 1. For example, let's take a look at these two. The square root of 24, well, that has a 4 in it, so we can take the square root of 4 and get 2, and we pull that out and we get 2 radical 6. Here, the cube root of 24, well, that's got a perfect cube in it, so we do the same exact thing. We've been doing this part right here might be a little bit new. That's a really bad star. So this will be a little bit new, okay? But we just have to find, you got to know our perfect cubes, really. So we look here, we have the cube root of 54x to the 5th. Well, we can rewrite that, okay? And this is good because this is how we've been rewriting it. Perfect cube that goes into is 27. So this is 27 times 2. And then we can rewrite x to the 5th as x cubed and x squared. Then we take the cube root of 27, which is 3, the cube root of x cubed, which is x, and underneath the radical, underneath the cube root, which I was the 3 off that one, we still have 2 and x squared. Okay, so go ahead, and I know that new, I get it. All right, you can do it, I promise. Try and do number 2. It rhymes. Try and do number 2. Pause the video right here, and then when you unpause, I will have the answer. So go ahead and pause the video now. All right, you've unpaused. The answer is, are you ready? 4x squared times the cube root of 2x. Okay? If you got that one, good. If you didn't, make sure you make a note of it somewhere, and we will go over how to do that problem in class. All right? Let's look at this one, simplifying a product. So problem 2, all the way back up here, involves simplifying a cube root, so absolute value symbols are not needed. Remember that to combine the nth root of a and the nth root of b by multiplication, both radical expressions must be real numbers. Okay, real numbers. So, what is the simplest form of this? All right. So what we can do is we can combine them because it's same index, 2 and 2. So 72 times 10, and we get 720, and x cubed times x is x to the 4th, and y squared times y cubed is y to the 5th. And then we have to clean these up and find the largest perfect square that goes into it, which ends up being 144. And we do all that, and we get all the way down to here. And I know I told you guys don't worry about the absolute values. I still mean it. Don't worry about the absolute values. We'll come back to that later if we need to. All right. So do me a favor. Let's go ahead and simplify this, okay? You're going to have to multiply the 45 and 35, the x's and y's, and then take the square root of that, all right? So what is the simplest form of this? Pause the video and give me an answer to that. All right, you've unpaused. Hopefully you got 15 x cubed y cubed times the square root of 7y. Again, if you didn't get that, I would suggest trying the problem again. Maybe you can find your mistake. If you still can't, make note of it somewhere, and we will go that problem and how to solve it, or how to simplify that in class. Since we defined division in terms of multiplication, we can extend the property for multiplying radical expressions. So basically, because multiplying is the opposite of dividing, really, because we can do this, we can also do this. Because we can do this, we can also do this. So if, here's the property, if the nth root of a and the nth root of b are all real numbers, then the nth root of a over the nth root of b is the nth root of a over b. Okay, again, we need the index, we need that to be the same, and if it is, we're good to go. So here, this is a square, this is a square, so we can combine them to one fraction. Do the division here, 18 over 2 is 9, x to the 5th over x cubed is x squared, and we take the square root of that and we get 3x. Okay, here, again, cubes, same thing applies, we simplify, we work all the way down. Alright, for a, what is the simplest form of this? So we'll do this one together. We combine it into 1. This is now 50 x to the 6th over 2x to the 4th, which is 25 x squared, which is 5x. All right. Part B says, can you simplify the expression in problem 4, A, the first part, by simplifying 18x to the 5th and 2x cubed? Can you do that? Okay. See if you can pause the video and see if you can actually do that. Pause the video here and try that. So you may have gotten stuck on this one, so I'm going to walk you through it. 18x to the 5th, we have 18x to the 5th, okay? Radical. So we're going to take that and we're going to simplify that, okay? There you can see. And then we're going to simplify this 2x cubed, okay? So if we do that, we end up with, this is 9 times 2, so 3 comes out. This is x to the 4th times x, okay? So we can take out x squared, and then all that's left is 2x underneath the radical. Here, I can take the square root of x squared, and x comes out, and 2x is underneath the radical here, and then this divides out with that, this divides out with that, and all I'm left with is 3x. So you can, it's a little bit more complicated to do it that way rather than combine it and do it all at once. All right. Another way to simplify a radical expression is to rationalize the denominator. We've done this year. We've worked on this. It's going to get a little bit harder because we're going to work with radicals that aren't just square roots. But we want, in any simplified answer, there can be no radicals in the denominator. Okay, no radicals in the denominator. So let's look at what that looks like. What is the simplest form of the cube root of 5x squared over 12y squared z? The big thing here is that we need the denominator to be perfect cubes, okay? We need the denominator to be perfect cubes. So right now we have it as 12. So we can change 12 to be something else. Here, what they've done is they've separated it into top and bottom, first of all. And so on the bottom we have 2 squared times 3y squared times z, okay? So what we do is, and we've just separated the 12, so it's 2 squared and 3, okay? If we multiply that by 2, that would be 2 cubed. Multiply this by 3 squared, that would be 3 cubed. Okay, we just separated into the factors, and now we're finding a way to make them cubes. Y squared multiplied by y would be y cubed. Z multiplied by z squared would be z cubed. So since this is what we're multiplying the bottom by, we're going to multiply the top by the same thing. Okay, so we do that top and bottom, and then we just work our way through the problem and simplify. Okay, so here the correct answer ended up being A. All right, so let's go ahead and try to do that on 5A. I'm going to give you a chance to try it first. Okay, 5A, see if you can rationalize the denominator and see what you get. Okay, go ahead and try that now. All right, you've unpaused. Hopefully you got this, the cube root of 175xy all over 5y. If you didn't, put a star, try it again first of all if you didn't. And if you didn't, if you still don't, put a star or something by it and we'll go over that in class. Part B, which choice in problem 5 could be eliminated immediately? So go back to this, which could be eliminated immediately, and that should be easy. B could be eliminated immediately because It had a radical, good lord. It had a radical in the denominator still, so we know that that's not the answer. Okay. Also could have eliminated D immediately because there's no Y in that expression. So right off the bat, we can eliminate B and D. Okay. That is it for the notes today. Make sure that those problems, if you didn't get them right, you try them again. And if you still don't get them, you make note of it, and we'll go over them in class. Do me a favor. Retweet the tweet that you found this in, or like the video, or share it on Twitter, or do something. Some of our classmates need help finding the videos, okay? Help somebody out. It'll be good for them, and you'll feel better about yourself. And hey, isn't it all about us anyway? See you next time. Bye.